Hey y'all, happy Monday. So glad you're joining us for our synchronous class. Today we're going to wrap up our adding and subtracting of fractions with unlike denominators. We're really going to spend our time today practicing that. If you have questions while you're working through these problems, let me know. I'll be available online all day tomorrow, or you can send me a Schoology message today, and I will respond as quickly as possible. Again, today is Monday, not November, Monday, April 19th. It is a great day for a great day. So let's dive on into what we're doing today. After we spend some time practicing some problems with adding and subtracting fractions, we will talk about volume for just a little bit. But y'all, let's get started with some practice here. I hit the right button. Look at me. Way to go, Mr. Spencer. So first off, before we really start, I'm going to cover this up and move this up here. Y'all remember there are 3 steps. Now we wrote down these 3 steps to solving addition and subtraction problems on Friday. So you should have these in your notes already. If for some reason they're missing from your notes, or they flew out the window, or your turtle ate them, please write them down. They are these 3 things. First, find the like unit or the common denominator. That's our first step. And there's a number of different ways that we can do each of these steps, which is super cool. But they're the 3 steps we need to do. So first, we're finding the like unit or the common denominator. That bottom number in our fractions needs to be the same before we can add or subtract them. Our second step is to create those equivalent fractions. That's where we're taking the original fraction problems and rewriting it with equivalent fractions. And then our third step is just to add or subtract. Once we have that common denominator or the like unit at the bottom of our 2 fractions, we're able to just add or subtract the numerator and get our answer. So, one more time, you probably have these written down in your notes already. If you don't, write them down now. You will want them the rest of this week and the rest of our 5th grade year. But I'm going to release you with 6 problems to do. Here are the 6 problems, and wow, I fit perfectly right there. Look at that. A, B, C, D, E, and F. Take your time, solve these 6 problems. I'm going to go on and talk about volume, so you're going to want to pause the video, but solve these 6 problems. Make sure that you find that like unit or common denominator first. We can't just add the numerators and the denominators. Can't do it. We've got to find our like unit, the common denominator, and then we need to create those equivalent fractions, and finally then we're able to add or subtract. So that's what we're doing. There we go. And go. Okay, if you haven't paused the video yet, pause it now so you can solve these 6 problems. I'm going to get into talking about volume for just one little bit. But before we talk about volume, we've got to talk about some other things. We're going to start with a square. And in our square, we remember, and we probably already remember volume too, but we may not. It's okay. We'll get there together today. So in a square, there are 2 different things that we really care about. And it's true of any shape. Specifically, we've talked about rectangles, so squares and rectangles. I think we've also talked about some triangles. But today, and in 5th grade, we just worried about volume of rectangular prisms. Remember, those are boxes. But before we start with our rectangular prism or our box, we're going to start with this rectangle that is flat. It is 2-dimensional. There is no thickness to this, so there are 2 things. We're going to end up writing down 3 things together. The first, if you don't have a box like this, please draw a box like this, just this square. It is a square, so it is 2-dimensional. Draw this square in your notes here. And the outside should be dark and thick, and the inside should be shaded in. So I use blue, and then my inside is yellow. So I want you to take, once you've got your, I should pause here for just a moment to make sure you have time to draw your shape and shade it in. If you can shade it in with a different color, that is awesome. If not, that's okay too. All right. So I want you to take your finger, and I want you to trace the outside of the shape. For me, it is the blue area. So over here, I want us to think about what that is. Hmm. And I'm going to draw mine here. And I'm going to draw a rectangle here because right now we have a square, but all squares are rectangles, and you'll see why we have a square in just a moment. But here we have a rectangle that is just the outside. And that, we remember, is the perimeter. Perimeter. And for that, it is the outside. And all of this is probably familiar to us, which is awesome. I'm going to slide that over so we can see everything. But we're spending some time today reviewing just to make sure it stays fresh in our head, because this is some of the most applicable math that you will use ever. And oh, there goes the cap of that marker. Anytime you are building something or putting up wallpaper or painting or putting a floor somewhere or trying to build anything, trying to figure out how much water you are drinking every day, you're going to need these things. So the first thing is perimeter. It is the outside. And when we solve perimeter, we add all the sides. Our next, I would use yellow to write this, but it is too light, so I'm going to use orange. The next is the inside. What do we call the inside of our rectangle? I want you to think about that while I pick up my marker cap here. What do you call the inside of our rectangle? What do you call the inside? Absolutely, that is area. Area is the inside. Now I want you to shade in the area with your finger on that square we had here. Area is the inside. So in our two-dimensional shapes, we've got two things. We have the perimeter, that is the outside, and area, that is the inside. Well, y'all, we're going to do a little bit of magic. We're going to take the square, we're going to cover it up, we're going to wave our hand over here. We're going to go abracadabra, and there we go. We have a three-dimensional shape. We have taken our two-dimensional square, and we have added that third dimension. So before we had this side and this side. Oh, also to find the area, we multiply the length times the width. Y'all, I hope you thought my magic trick there was very cheesy. Length times width. And once we add that third dimension, we now have the length, we have the width, and we have this other one called the height. Now what do we call the height? What is that? Well, I'm going to start down here. We've added in that third dimension. And to solve this, to find out that third dimension, we do length times width times height. And what is that? Well, when we try to find out how much space this takes up, we're still thinking, what is this called? And we're going to note that that is 3D. And when we're solving that, how much space does this take? Wow, we're really off the page here. Gee, Mr. Spencer. My face is getting in the way. When we ask ourselves how much space does this take up, and we're multiplying length times width times height, we are finding the volume. And the volume is how much space an object that is 3 dimensions takes up. Okay, I dropped my whole marker again, so I'm going to pick that up. And then we're going to move on. So, you have your square here. Your square probably looks something like my square. And I'm going to draw my square in blue because our outside is blue. I'm going to draw it three-dimensional because now we have a cube. And we're going to label this side length here is 6. This side length here is 6. This side length here is 6. And we are going to try and find our perimeter. And to find our perimeter, we are only worrying about one side of our cube that we drew. So only the square. And this can get a little tricky because we know for the perimeter we add up all the sides, but we also only see 2 side lengths here. So you might think 6 plus 6, our perimeter is 12. But don't forget that this side is the same length as this side, and this side is the same length as this side. And we have 1, 2, 3, 4 total side lengths. So we have to do 6 plus 6 plus 6 plus 6. And for this, everything is going to be in centimeters. That is going to be our unit. 6 centimeters plus 6 centimeters plus 6 centimeters plus 6 centimeters. And that equals 24. So you have 6 plus 6 plus 6 plus 6 equals 24. 24 what? 24 centimeters. Now, it is just centimeters because we are right now in the first dimension. We're just looking at the length of our lines. But up next, we're going to look at the area. And to find the area of this, we do length times width. Again, we're just looking at the orange square. So we have 6 centimeters times 6 centimeters. And I know that the area is 6 times 6. And 6 times 6 is 36. Our unit is centimeters. But hold on, we're now multiplying. And when we multiply, we're really finding out, wow, that looks like our rectangular fraction model there. So we've split this box into 6 groups this way and 6 squares this way. And we've ended up with 36 total squares. But we're finding the area. And we've made these into squares. So our answer needs to be centimeters squared because we're talking about how many squares there are in total. In this square, there are 36 unit squares. And how big is the unit? The unit is a square centimeter. Okay? And so this perimeter is in the first dimension, so we have just centimeters. Area is in the second dimension because now we're going 1, 2. It is flat still, but we have 2 ways that we're going. And so our answer is centimeters squared. And then we have volume. And our volume takes into account that third dimension. So we have our length of 6 centimeters, our width of 6 centimeters. So far we are the exact same as the area. And then we're going to multiply by the height. That is also 6 centimeters because we are in a cube. All right, so we have 6 centimeters times 6 centimeters times 6 centimeters. So we have 36 times 6. Do that right here. Is 216. But it's 216 what? Now we're in the third dimension. We are a 3D shape here. Oh. When we were just in a perimeter, we were just in a line, the outside. So we had just centimeters. When we were talking about area, we were talking about the squares in our square, the individual unit squares. Now we're in the third dimension, so we're asking ourselves how many units are in here, and what is the unit? This is a cube, right? So when we're talking about volume, we're saying how many cubic units or cubes are there. So we're going to put a 3 because we would say centimeters cubed. And that 3, remember, we talked about first semester so long ago, meant cubed. It also stands for that third dimension. We're in 3 dimensions now. Awesome. Well, that is where I'm going to leave you for today. We got some good notes that is going to help us tomorrow. Tomorrow is going to be an asynchronous day. That means we're working on our own. Wednesday is also going to be an asynchronous day if you are a virtual scholar. If you are an in-person scholar, we are going to take the ELA TCAP on Wednesday. Thursday will be an asynchronous day for our in-person scholars. And for our virtual scholars, it is your day to come into the building so you can take the ELA TCAP on Thursday. If you're virtual and don't know how to get to the school, we have all of your bus information, or we can answer any questions you have. Just shoot me a message, and I'd love to help you out, or Miss Hayden or Mr. Barton or anybody else in our school. And then Friday is going to be a synchronous day for everybody, but on Friday we're going to start talking about the coordinate plane, and I am super excited about that. I love it. We're going to take a crash course in it, and we are going to start with Battleship. All right, y'all, that is it for today. Have an amazing day, and I will see y'all soon. Goodbye.